Hello everyone. This one is another video on measures of central tendency. The objectives: how to find the mean, median, and mode of a population and of a sample. So I'm talking about population and sample in this case. How to find the weighted mean of a data set, and how to estimate the sample mean of group data. How to describe the shape of a distribution as a symmetric, uniform, or skewed, and how to compare the mean and median for each. So in terms of measures of central tendency, we look at into the definition, a value that represents a typical or central entry of a data set. And when we talk about a data set, that refers to all of the data being collected. So in terms of assessment of learning, all of the scores collected from the students, from the learners, or from the pupils in general can be classified as data set. I mentioned earlier about population. So for example, there are 100 students and you consider one as the total number of students that you have, and then you have collected data from those 100 students as the total number of students in the group. We classify that data set as a population. However, it will take on the sample of the entire members of the group. For example, out of 100, you take only 80, you take only 70. The 80 or the 70 are being considered as representative of the total number of members. Then we classify that 70 or that 80 as a sample. So in general, in statistics, we classify sample as representative of the total population. And the population would refer to all members of the class, all members of the group. The sample are only representative students of the class, representative learners of the class, or representative pupils of the entire class. Measure of central tendency would refer to mean, median, and then mode. According to that slide, most common measures of central tendency, we have mean, median, and then mode. Mean or average. In some books, we classify that one as arithmetic mean, the sum of all the data entries divided by the number of entries. We have sigma notation. We have summation of x. So we classify that one. We read that one as summation of x. Add all of the data entries. Add all the x's in the data set. And then we have the population mean. That is a Greek letter mu. It looks like a small letter u, but there is a Greek letter that's pronounced as mu, is equal to summation of x divided by capital letter N. And that capital letter N would refer to the total members of the population. And we have the sample mean, x bar, is equal to summation of x divided by small letter n. So take note of the difference between capital letter N and small letter n. And small letter n would refer to the sample, and capital letter N is referring to the population. Mu would refer to population mean, then X bar would refer to sample mean. So take note of those different symbols. X bar, sample mean, mu would refer to the population mean. So here's an example in finding a sample mean. The weights in pounds for a sample of adults before starting a weight loss study are listed. What is the mean weight of the adults? 274, 235, 223, 268, 290, 285, then 235. So what you are going to do is add all the data given And we call that one as the summation of x. So 274 plus 235 plus 223 plus 268 plus 290 plus 285 plus 235. So the total is 1,810. And that refers to summation of x. Then since the data are taken from a sample, so we make use of the formula x bar is equal to summation of x divided by smaller n. So we have 1,810 summation of x, and our total number of sample is 7. So when we divide 1,810 by 7, so we have a rounded off value of 258.6. So take note when you divide and then the quotient is not exact, you are not going to use equality. But this kind of symbol in here is what we call approximation. When we say approximation, this kind of symbol, meaning the value is rounded off, 258.6 up to 1 decimal place. So what does it mean when we say x bar, or the sample mean is 258.6 approximately? So there are actually 3 interpretations for that, as mentioned in video number 1 of the measures of central tendency. So it might be that the weight in pounds is exactly 258.6. That is one possibility. The second one, it might be a little bit lower than 258.6, or it might be a little bit higher than 258.6. So looking into that value of the mean, there are 3 possible interpretations. So if the sample mean is approximately 258.6, there are 3 possible interpretations. It might be that the weight in pounds in there is exactly 258.6, or it might be a little bit lower than 258.6, or it might be a little bit higher than 258.6. That's the interpretation. In terms of median, the value that lies in the middle of the data when the data set is ordered. In the previous video, video number 1 about measures of central tendency, I mentioned there that when you calculate the median, you have to arrange first the data from lowest to the highest, or from the highest to the lowest one. So we classify that one as ordered pair. And measures the center of an ordered data set by dividing into 2 equal parts. So you get the middle portion, the middle value, and dividing that one into 2 equal parts. So if the data set has an odd number of entries, median is the middle data entry. I mentioned that one in my video number 1 for measures of central tendency. For even number of entries, the median is the mean of the 2 middle data entries. So here's an example. Find the median of the weight listed in the first example. So we have 274, 235, 223, 268, 290, 285, then 235. So first, order the data. You are going to see to it that the data are being ordered from lowest up to the highest one. So we have 223, 235, 235, 268, 274, 285, 290. And count the total number of entries, or the total number of data. So we have 1, 2, 3, 4, 5, 6, 7. So we have odd number of entries there. And according to the statement earlier, it is equivalent to the middle item. So there are 7 entries, an odd number. So the median is the middle, or the 4th data entry. So if we are going to look at here, we have 1, 2, 3, 4. We have 1, 2, 3, 4. That's actually the 4th item starting from the lowest one, or the 4th item starting from the highest one. 1, 2, 3, 4. How do we get 4? The total number of entries is 1, 1, 2, 3, 4, 5, 6, 7. So if the total number of data or entries is odd, then you are going to add 1 to the total number of data entries. So we have 7 plus 1 will give you 8, then divided by 2. Divided by 2 because median divides the total data set into 2 equal parts. Why plus 1? Because our total number of data entries is odd. So counting, so we have now 1, 2, 3, 4. We have 1, 2, 3, 4. So that's the middle. It's the median 268. So in here, the median weight of the adults is 268 pounds. So what does it mean if the median weight is 268 pounds? That means 50% of the total number of data have values equal to 268 pounds or maybe less than 268 pounds. The other 50% of the total number of data have values equal to 268 pounds or higher than 268 pounds or heavier than 268 pounds or greater than 268 pounds. So why 50-50? Because our total percentage is only 100%. Dividing that one into 2, so we have 50%. So the 50% is the lower part, the other 50% is the upper part. In the previous example, the adult weighing 285 pounds decide not to participate in the study. So what is the median weight of the remaining adults? So we have now 223, 235, 235, 268, then 274. And if you count the total number of data, the total number of data is 1, 2, 3, 4, 5, 6. It is even. So if it is even, divide that one exactly by 2. And why 2? Because median divides the data into 2 equal parts. So 1, 1, 2, 3, 4, 5, 6 divided by 2. So we have 3. So count 3 starting from the lowest one, 1, 2, 3. Then count also 3 starting from the highest one, 1, 2, 3. So you notice that we have 2 middle items. To get the median, you get the average of the 2. That means you add the 2, then divided by 2. So we have 235 plus 268 divided by 2. So we have 251.5, no? 251.5. If the division is exact, then you can use equality. If the division is not exact, then you are going to use approximation. So the interpretation there, the median weight of the remaining adults is 251.5 pounds. And what does it mean in a deeper sense when we interpret the value of the median? So 50% of the total number of data have weights equal to 251.5 or maybe lighter than 251.5 or maybe less than 251.5 pounds. The other 50% have weights equal to 251.5 pounds or greater than 251.5 pounds or heavier than 251.5 pounds. So take note of that interpretation. We look at into mode as the other measure of central tendency. So mode refers to the data entry that occurs with the greatest frequency, or the number or the entry that appears many times or frequently appear in the data set. If no entry is repeated, the data set has no mode. No, I mentioned that one already in the first video about measures of central tendency. If 2 entries occur with the same greatest frequency, then each entry is classified as a bimodal. So here's an example. Find the mode of the weights listed in example number 1. 223, 235, 235, 268, 274, 285, then 290. So if you notice 235, we go back. 235 is appearing twice. And that's the only number that is appearing twice. All of the rest, all of the data found in the set are not appearing twice or even three times. They appear only once. So the mode is equal to 235 pounds. And when say the mode is 235 pounds, that is actually the weight that is appearing frequently in the data set. So finding mode in a given frequency table. At a political debate, a sample of audience members was asked to name the political party to which they belong. The responses are shown in the table. What is the mode of the responses? So we have political party, Democrat, Republican, Independent, then other don't know, with the corresponding frequency, 46, 34, 39, and then 5. So if you look at into the value of the mode, you refer to the highest frequency. So the highest frequency is 46. So the modal party is Democrat. So we have here the solution. The response occurring with the greatest frequency is Democrat. So the mode is Democrat. In this sample, there were more Democrats than people of any other single affiliation. So the modal political party is Democrat. So that's how you are going to calculate the mode in a given frequency distribution. Comparing the mean, median, and then mode. So how do we compare the mean, median, and mode? So all three measures describe a typical entry of a data set. Advantage of using the mean. So the mean is reliable measure because it takes into account every entry of a data set. So if you notice all the data are being added, then divided by the number of data. So each of the datum in there is accounted in calculating the mean. So that's why we say it's a reliable measure. Disadvantage of using the mean. Greatly affected by outliers, no? A data entry that is far removed from other entries in the data set. So if you look at video number 1 about measures of central tendency, there's a part there that I explain about outliers. So if you want to know more about outliers, go back to video number 1 about measures of central tendency. So comparing the mean, median, and mode, the table shows the sample ages of students in a class. Find the mean, median, and mode of the ages. Are there any outliers? Which measure of central tendency best describes a typical entry of this data set? So calculating. So we can add all the data. So X bar is approximately 23.8. So why approximately? Because the value is rounded off. If the quotient is exact, then you have to use equality. Median. So we have 21.5 years. And then the mode, 20 years. The entry occurring with the greatest frequency. So 20 years. So take note, mean 23.8. The median is 21.5. The mode is 20 years. So if the mode is 20 years, that would refer to the modal age, not 20 years, and that is the age that is repeated most of the time found in that given data set. The median is 21.5 years, meaning 50% of the total number of data have values equal to 21.5 years, or maybe less than 21.5 years. The other 50% are greater than 21.5 years, or maybe equal to 21.5 years. To contextualize about age as the given variable and the quantity is being measured in terms of years. So we say 50% of the total number of data are aging 21.5 years exactly, or The 50% in there are actually aging younger than 21.5 years. And the other 50% are aging exactly 21.5 years, or that is actually older than 21.5 years. If I say that one in a contextualized manner, according to the kind of data that we're talking about in that given. And in terms of the mean, approximately 23.8 years. So there are three interpretations there. So the age may be exactly 23.8 years, or maybe a little bit lower than 23.8 years, or maybe a little bit higher than 23.8 years. Or in a contextualized manner, so we can say that the age is exactly 23.8 years, or maybe a little bit younger than 23.8 years, or maybe a little bit older than 23.8 years. So take note of the interpretation. So let's have the continuation. We have mean is approximately 23.8 years, median is 21.5 years, mode is equal to 20 years. The mean takes every entry into account, but is influenced by the outlier 65. So let's go back to the data. If 65 is an outlier, so you notice that the majority of the data are 20. You have 20 plus 20, then 20 plus, but we have 65. This 65 is classified as an outlier. Why outlier? Because it is actually considered a big value in comparison to the majority of the data. So we classify that one as outlier. And then the median also takes every entry into account and is not affected by the outlier. In this case, the mode exists, but it does not appear to represent a typical entry. So comparing the mean, median, and mode, sometimes we look at that one in a graphical perspective. So we graph the data, age of students in a class, the data, this kind of data here. So these data are being graphed. And for now, you can do the graphing manually, or you can do the graphing through the use of Microsoft Excel. I assume that everyone knows how to make use of the Microsoft Excel. So your activity is graph the data. Given this kind of data, take a screenshot for that, and then graph that one using Microsoft Excel. Okay, so that's the graph, and that is actually a computer-generated graph. So we have now the location of the mode, it's in here, the location of the median, and we have the mean. So if you look at the median is actually at the middle from the term itself, median. So that should be at the middle part. Mode is actually referring to the tallest one. There are examples in video number 1 about measures of central tendency, and that looking at the graph, if we determine the mode, that refers to the tallest as found in the graph. And then the mean is actually in the right side, and is actually being affected by the outlier. So if you look at 65, it is an outlier. This is very far from the majority of the data. So in this case, it appears that the median best describes the data set. Then we go into weighted mean. So we normally do that in terms of looking at data with different weights. No? So let's have here. Okay. The mean of a data set whose entries have varying weights. No? The weighted mean is given by x bar is equal to summation of xw divided by summation of w, where w is the weight of each entry. So here's an example. So your grades from last semester are in the table. The grading system assigns points as follows. A is equal to 4, B is equal to 3, C is equal to 2, D is equal to 1, and F is equal to 0. Determine your grade point average, weighted mean. So final grade, C, C, D, A, C, and then B. Credit hours 3. We have 4, 1, 3, 2, and then a 3. So we have points. So we have 2, 2, 1, 4, 2, and then 3. The credit hours, so we have 3, 4, 1, 3, 2, then 3. Then we have XW. So we have 6, 8, 1, 12, 4, and then 9. So credit hours, so we have the summation of W. So if you're going to get the total for all these numbers, the total is 16. And then XW, the product of the first and second columns. So we have 2 times 3, 6, 2 times 4, 8, 1 times 1, 1, 4 times 3, 12, 2 times 2, 4, 3 times 3, 9. So adding all of this will give you a summation of XW. So the total is 40. That is 6 plus 8 plus 1 plus 12 plus 4 plus 9. The total is 40. So the formula is X bar is equal to summation of XW divided by summation of W. So we have summation of XW 40 divided by summation of W16. So 40 divided by 16. So if the quotient is exact, you use equality. If the quotient is not exact, you round it off, then you have to use approximation. So we have weighted mean is 2.5. What does it mean if the weighted mean is 2.5? We look at grades nga some are exactly equal to 2.5, some are a little bit lower than 2.5, and some are a little bit higher than 2.5. And then activity for this, I want you to get a copy of your second semester grades. No? So last year, second semester grade. Get a copy of that one and try to manually compute your weighted mean or the GPA. No, we call it one as the GPA. The GPA, when you get a copy of your GPA, a copy of your grades, no, in the previous semester, it's actually found in the office. You can actually get a copy of that one or from the registrar's office. So it's generated. Now, you know already how to calculate the weighted mean or the GPA. I want you to manually compute the GPA of the second semester grade. So in here, you have the grades to be written in the first column. And then the units of the subjects that you have taken are referring to the second column. So these are the grades of all the subjects, and these are actually the units. So these grades are actually the grades of all the subjects. So as a modification, you add another column before points. You add here subjects in the second semester. Subjects in the second semester and the corresponding grades of those different subjects, and then the units of those different subjects. Then follow the same process. Then calculate your GPA. And then you are going to submit that one on Monday. You're going to submit that one on Monday if you belong to Monday class, no? Entry O2 Monday. If you belong to Friday, then submit your GPA manually computed based on this sample on Friday. Okay, so take note of that. And one thing that you are going to remember, if it is actually an INC automatic, that is actually given as 5.0, no, in the computation. So it's 5.0 drop, 5.0, INC is classified as 5.0. You might have a subject na INC, but you have there the GPA. The computation in there is that your INC is assumed as 5.0. Okay, mean of group data. So there are actually group data. No? We'll be talking about frequency distribution later. So mean of a frequency distribution. So approximated by x bar is equal to summation of xf divided by small letter n. And small letter n is equal to the summation of all frequencies, where x and f are the midpoints and frequencies of a class, respectively. So we look at here some of the steps that you are going to consider. So in words and then in symbols. So find the midpoint of each class. So we have x is equal to lower limit plus upper limit divided by 2. Number 2, find the sum of the products of the midpoints and the frequencies. That's summation of xf. Number 3, find the sum of the frequencies. That is, small letter n is equal to summation of f. Then find the mean of the frequency distribution, and that is x bar is equal to summation of xf divided by small letter n. So here's an example. The frequency distribution shows the out-of-pocket prescription medicine expenses in dollars for 30 US adults in a recent year. Use the frequency distribution to estimate the mean expense. Using the sample mean formula, the mean expense is 285.50. Compare this with the estimated mean. So we have now the class midpoint. We have x 172.5, 208.5, 244.5, 280.5, 316.5, 352.5, 388.5. The frequency, we have 3, 2, 5, 6, 7, 4, and then 3. Then we have the total for n 30. Then xf, the product of the class midpoints and then the frequency. So we have 172.5 times 3, 517.5. 208.5 times 2, 417.0. So for Tanson, up to 388.5 times 3, so 1,165.5. You get the total of the frequency column, that's 30. 3 plus 2 plus 5 plus 6 plus 7 plus 4 plus 3, the total is 30. You get the total of the third column or the xf column. So add all these values from 517.5 to 1,165.5. So the total is 8,631. And the word, the symbol summation refers to the total. So x bar is equal to summation of xf divided by summation of n. So 8,631 divided by 30. So we have 287.7. So we have here, the mean expense is $287.70. This value is an estimate because it is based on a class midpoints instead of the original data set. If you look up into the original data set, the data set not being converted into frequency distribution. So it is given in here, 285.50. But if you are going to have the frequency distribution table, it's actually 287.7. Again, when we interpret that one, 287.70, we can say that the mean expense is exactly 287.70, or it might be a little bit lower than 287.70, or it might be greater than, a little bit greater than $287.7. So take note of that interpretation. Then we have the shape of the distribution. We are talking about skewed distributions. In video number 1 about measures of central tendency, I talk about skewed distributions or the shape of the distributions. So symmetric distribution. Looking at the graph, wherein the graph is generated through a computer, A vertical line can be drawn through the middle of a graph of the distribution, and the resulting halves are approximately mirror images, meaning from the word symmetric distribution, from the center, then the other bar graphs are having symmetry. So this one and this one are symmetrical. This one and this one are symmetrical. So you look at starting from the center, the tallest one. If you look at the graphs in the left side and the graphs found in the right side, they are actually symmetrical. In terms of heights, they're actually the same, looking at the left graph and the right graph. And that's the reason why we call it one as symmetrical distribution, because there is a point of symmetry between the graph found in the left side and the graph found in the left side. Uniform distribution. So when we talk about uniform distribution, the heights of the graphs are exactly the same. And mean is equal to median in this case. And all are actually having the same heights. Then we have the skewed left distribution. Skewed to the left distribution, skewed left distribution in this book, or negatively skewed. The other term of skewed to the left is negatively skewed. When you look at mean, median, and then mode, if mean is less than median and median is less than mode, then we classify that one as negatively skewed distribution or skewed to the left. Or it can be in the reverse one. No? Mode is greater than median and median is greater than the mean. We classify that one as negatively skewed or skewed to the left distribution. We're looking at the graph. The bulk of the graph are found in the right side. And the skewness is actually found in the left side. You notice that the skewness in here is found in the left side. So we have skewed to the left or the negatively skewed. Skewed to the right distribution or positively skewed distribution. This will happen if mode is less than median and median is less than mean. Or from the right side going to the left side, mean is greater than median and median is greater than the mode. We classify that one as positively skewed or skewed to the right distribution. Or looking into the graph, you look at some that majority of the data are actually bulking in the left side. And the skewness is found in the right side. That's why we classify this one as skewed to the right, because the skewness is found in the right side. And the other term of skewed to the right is positively skewed. So take note of that. It may go back to this one, skewed to the left and skewed to the right. So how do we look at that one in terms of a class representation? If a majority of the students in the class are actually doing good and only few are not doing good. So looking at the scores will be towards this part, bulking into the right side. Wherein the right side are actually higher values. If you look at the graph, if you go to the right side, the values are actually going bigger. So the graph also are having bigger values. So meaning, if we talk about scores, then these graphs are actually corresponding to higher scores. And these scores are corresponding to lower scores. So if you look at the graph, only few are having lower scores, but majority of the set are having higher scores. And this would happen if majority of the class are doing good. If they're doing good, then the scores are actually higher, and only few are not. And if they're doing into a case that they are not doing good, then the scores are actually lower. And we classify that one as skewed to the left or negatively skewed. Looking into skewed to the right or positively skewed distribution, how do we apply that one in class setting? There might be a case nga majority of the students are not doing good. Only few are doing good. So what will happen if only few are doing good? Only few will get the higher scores. And majority of the students will get lower scores. So this one would correspond to lower scores, and only few are getting higher scores because only few are doing good. Majority are not. So the scores are actually lower, and many of them are having lower scores. And that would be classified as skewed to the right or positively skewed distribution. And then let me go back to the, the symmetric distribution. The symmetric distribution. If we're going to look at into the symmetric distribution, or we call this one as the normal distribution. Normal distribution or symmetric distribution, wherein you are going to consider that the students are composed of good students, and then the not good students, and then the average students, the below average students, and the above average students. So if you look at the tallest part, this would refer to the average students. Then we go to the above average in this part. And this one would refer to the very good students. And in the left tail, these are actually referring to the not good students, or those in the lowest part of the group or the class. And this one, starting from the tallest one, the average, this part in here would correspond to the below average. So this would happen if you've got average students, you've got above average students, you've got also below average students, and you've got also very good students, and then the not good students. And that there is actually a proportionality of the above average and the below average. They're actually of equal proportion. Those students who are doing good and not doing good are also of equal proportion, so that we can say there is symmetry of the distribution, or there is what we call normality of the distribution. And that this graph, as I mentioned earlier, whatever you see in the left side can be seen also in the right side. They have the same heights as you see in the left and as you see in the right side for all of those graphs. So there is what we call a point of symmetry. So those are the practical applications of symmetric distribution, or the normal distribution, the skewed to the right or the skewed to the left distributions. So thank you very much and have a blessed day.